All right, here's the last calculus important rule that we have to prove. So, let's do the cheap proof first. So f of x equals to g of x over h of x. That's okay because it's a quotient rule, right? But another way to write this is g of x multiplied by h dash of x minus 1, not inverse, reciprocal. So if we do the product rule, we will expand this as g dash of x multiplied by g h of x minus 1 plus g of x times the derivative of the reciprocal, h of x minus 1. Or there's another big brackets there. So a lot of brackets, but that should be fine. So the derivative of this side is still fine, because this is done and dusted, just leave it alone. And this one is fine, just leave it alone. So product rule, we can bring this down, right? So we're really applying the chain rule here. So that is the chain rule. We have this minus 2 and then h dash of x, because the chain rule. So if you don't see how this works, you can think about it as 1 over h of x and h x dash negative 1. So if you apply the chain rule in there, we will get negative 1 at the front, h dash of x, and then h dash of x attached to be negative 2 there. That's how I got it from chain rule. Just practice a lot of chain rule and you see how that works. And just get rid of it, don't confuse anyone. So now it's just really a matter of grouping things together. So we have f dash of x equals to g dash of x over h of x plus, okay, what is this big mess doing here? H dash of x over, sure, minus hx squared. But yeah, so if you have this, we can just multiply everything by 1, just from nowhere. Why not? And that minus g of x, h dash of x. So it's like a product at the front. And then we have h x squared. So now, assume that we don't know the product rule and chain rule, so let's do a proper proof for it. So if we have f of x still equals to g of x minus h of x, then we can say f dash of x is equals to f of limit, I can't use h again, so limit of, let's say, k. I don't want to say delta anymore, it's too much effort to write it. So f of plus k minus f of x over k. Well, substitute things in, this whole big chunk is equals to g of x plus k. Forgot to write the limit. Limit of from k goes to 0 of g x plus k over h x plus k minus g of x over h of x, and the whole thing is over k. Already starting to look very ugly. However, there's an interesting thing that I haven't, see if we can notice. So if we do cross multiply-ish thing here, we have limit of k approaching 0 of 1 over k multiplied by, yeah, that's what we're going to do. X plus k times h of x minus g of x times hx minus k, plus k over k. So, why there's a k here? Sorry, this is not a k at the bottom. Got to get some sleep, too much mistakes going on. So this is hx plus k of h of x. Yep. Rearrange it, flip it around, we'll get limit of k approaching 0 of 1 over hx x plus k times, Sorry for letting you listen to me copy this down again, but I mean, it's calculus. Sometimes to working out it's just massive. X plus k, the whole thing is over k. This doesn't look good, does it? But we're almost there. It's okay. What is this thing approaches to? Okay, I forgot a big brackets at the front because it's a limit. This is very interesting, isn't it? This is k. We can put 0 in there and just get rid of k. So now we have 1 over hx squared. So at least now we get the first part down. Now we just have to get the top part. Wow, this is similar to what we did for the product rule, right? So we just have to get things out of nowhere. I just like to call it that way. X plus k of h of x minus g of x of hx plus k. So let's see what I'm going to get out of this time. All right, plus g of x, h of x, and then minus g of x, h of x. Have to be smart of what you're getting out of in thin air. So we can group this and this together, and then group this and this together. So back to the limit. X goes to 0. Actually, you know what? I don't have to care about that anymore. I can write this at the front because this is not in the limit anymore. K goes to 0. And okay, let's see. Grouping, very important. So we have h of x, whole thing of, actually, you know what? H of x multiplied by g of x plus k plus g of x over k plus g of x. Oh, it's a minus. Yeah, it's a minus. Oops. Minus g of x times h of x plus k plus h of x over k. Hey, see where I'm going? Let's just write the notes. This is equals to g. This is equals to g dash of x, and this is equals to h dash of x. Hey, there we go. So we can say that the derivative of d over dx of g over x over h over x is equals to h of x times g dash of x minus g of x times h dash of x over h of x squared. And this completes the proof. Yay!